A little bit about me real quick. Thanks for joining. I've been doing Microsoft for a long, long time. SQL Server since it was made of wood, 6.5. And well, the rest is history. I love this slide because I have Kubernetes and Azure and Linux on Windows and all of these things. Kind of in my recent past 5-6 years, I remember going up to Redmond and talking with some of the product owners up there. I realized real quickly that I need to learn Kubernetes and Linux for SQL Server real fast, and that's kind of what I'm going to show today, the entire stack, and at the end we're going to have a really cool, nerdy demo with a lot of tools that I'm going to use all at once in probably 10, 11 minutes, so that's going to be pretty cool. And then as a side hobby, I also do a little of this, and ironically, Steve and I went over here, which is not far down the road, an hour and a half, 2 hours, right, Steve? Yeah.
Over to you, yeah. Because
I had to find corgis in Pembroke. I did not find them, but my wife and I do breed and show those. That's my goofy little hobby that I do. Anyway, I thought it was ironic since I'm here doing that. But anyway, Dilip, you want to introduce yourself?
Yeah, sure. Can you hear me? Hi, can you hear me? Let me try the other way. Yeah,
there
I
it
think
goes.
this works. Good morning, everyone. My name is Dilip Ramachandran, and I'm from AMD. I work in the server business unit at AMD, and my responsibility is to work with partners on database and analytics solutions. And I've been collaborating very closely with Dell as well as Microsoft, and really excited to speak to you today about what we have together on the solution side of things, on SQL side, as well as Azure Stack HCI. Thank you.
Right on. Well, let's get started. So, agenda. HCI, Azure Stack, HCI, and then HCI with SQL and Azure Arc and Arc-enabled data services and Kubernetes. There's a lot of stuff in that box, a lot of stuff. The cool thing is, especially with products like Azure Stack, HCI, with the AMD solutions, they work very well. They work very seamless. It's super easy, especially when you use Kubernetes or K8s or K8s. So let's look at a few of some architectures here. But you know, there's a lot of boxes on the screen here, but starting kind of towards, let me see if I can get down here at the bottom with AKS, right? Everybody heard of AKS here? Anybody using it right now? Awesome, okay. Are you using it on HCI or up in Azure? What's that? We're beginning to use it, yeah. Oh, cool. So you're using it on HCI then? Yeah. Okay, perfect. Thank you. So then what that lights up is a lot of these services above that bar. And I can tell you that more and more services are going to be delivered with Microsoft that need that landing ground of some sort of Kubernetes. Does it have to be AKS? No, it can be any CNCF, Cloud Native Computing Foundation. I'm going to throw out all kinds of acronyms, but I'm also going to explain them. I'm kind of an anti-acronym guy. You have to actually explain the acronym. But then we light up a bunch more even above that bar. Policy management, update management, insights. You'll see that in some of my demos. Of course, the data services plugins, which is kind of why we're here today for that whole stack. And ironically, this whole stack, soup to nuts here, my partner and I, Mike Lamia, who's and also a technical marketing engineer like myself, just finished a brand new white paper on that entire stack. It's way cool. I'm pretty proud of it. It's in the slides here, or the links are here in the end. So our integrated system of HCI or AX nodes does really do everything those three boxes there really kind of list out. Accelerate innovation is the one that I really enjoy the most because it does allow us to move fast. It absolutely does. We did some lifecycle management testing. You'll see in some of my demos later where I had a bunch of HammerDB workloads running in a container on AKS, also Arc-enabled data services, and we started doing lifecycle management and even pulling the plug on certain nodes and seeing what happens in the cluster. And surprisingly, it was very resilient, especially with lifecycle management, draining a node, patching it, rehydrating. So you have a lot of that maybe challenging administration is now automated in a good way for everybody. But I'll let Dilip here talk about, you can push that big gray button to move it forward there, about AMD and what's inside the box, right?
Excellent. Thank you very much. So I'll spend a few minutes about giving you an update on where we are in our AMD technology roadmap, as well as how it's being used in this particular solution architecture based on Dell servers. So we introduced our third generation EPYC processors a couple of years back. They're codenamed 7003. And then subsequent to that, we also introduced a processor which was, we call it 3D V-cache technology. And that's the one on the right-hand side. And it's higher performance for cache-sensitive applications. So we've essentially tripled the size of cache on chip with our 3D V-cache version of the product. And essentially, we see quite a nice bump in performance when it comes to database applications running on top of the 3D V-cache products. So I'll go into a little bit more details about that. But we introduced this product. But since then, we've also introduced our fourth generation product, which we'll be talking to you about subsequently as we make solutions around that product as well. So what is this 7003 3D V-cache product? Leadership core performance. Essentially, we have 64 cores, again, very high performance cores. And, I'm going to step down here. And essentially, you're able to get much higher performance with these Zen 3 cores. And then I mentioned about L3 cache. This is the cache that's stacked onto the die itself. And you get 768 megabytes of L3 cache on chip. Again, if your applications are very cache sensitive, you could even see up to 50-60% improvement in performance. For database applications, we see about anywhere from 10 to 15% kind of improvement in performance with this increased L3 cache. And then it also has, it's pin compatible with the third generation product. So, essentially your platform that if you're using, let's say, third generation EPYC, you could migrate to this with just a BIOS update. And the last aspect is security. And AMD is known for its security leadership in the industry. We have some really unique features that I won't spend a lot of time here, but for you to be aware of, we have things like memory encryption, secure encrypted virtualization, as well as confidential VMs. Azure offers that today based on the AMD product. So there are a lot of interesting and really powerful security features that we have on chip. Again, by turning those on, you don't degrade the performance. A lot of it is done, pretty much everything is done in hardware, as well as I would say that you don't need to make any code changes to take advantage of these security features. Comes back to the basic question: why do you want to run SQL Server on AMD EPYC processor? You might be running it on, the Xeon processors today, and you might wonder why should I even change, right? The first area is really around better performance. And we've got several world records. You can see here 1 terabyte, 3 terabyte, 10 terabyte TPC benchmarks that are based on AMD EPYC processors, are industry leading in terms of performance. We have a very highly scalable processor. Again, being able to go from 16 cores or 8 cores to up to 64 cores, you're able to leverage the same hardware investment that you have in your server, in your Dell server, and really leverage that performance up and down the spectrum. And the third area is around energy efficiency. This is a key differentiator for AMD with respect to Intel and other products out there. AMD products are defined on, manufactured on very advanced process nodes, which saves a lot of power. And because of the performance, you can actually do also quite a bit of TCO improvement, because of overall power costs that you could save. That translates to better TCO. So we have several world records there as well. You can see some performance there on virtualized infrastructure, how we've been able to improve performance on running it on AMD hardware, and again, being able to deliver much better TCO. To give you a comparison here, I wanted to just share with you SQL Server running on AMD, how it does with respect to its competition. And here, comparing our third generation EPYC here, 7763, which is actually 64 cores per chip, or 128 cores in the system. And we're comparing it against the highest end second generation Xeon 8280, which has about 112 cores. And you can see here that we have essentially 40% higher performance at 20% lower cost per query. And here, again, on the Intel side, you are actually using 4 of these CPUs to get to 112 cores. We are able to do that with 2 CPUs. So that's some of the reasons why our solution is better in terms of performance, as well as power and energy savings. And this is my last slide, and I'll hand it back to Rob to continue with the architecture solutions. I want to mention to you today, we have more than 300 plus world records based on AMD EPYC, and they're in different areas. You can see here quite a few in business apps, business applications, a large number in data management and analytics, which might be relevant for you, as well as we have it in HCI, as well as in other areas, engineering, HPC kind of oriented workloads, et cetera. So this is based on our 4th generation EPYC processor. As of date, we have more than 300 plus world records and continue to grow with every generation of our products. So we've maintained this leadership in the performance leadership in the industry for now almost 5 years, and continue to do that for the foreseeable future. Thank you very much. Pass it back to Rob.
Thanks, Dilip. All right. Well, first let's talk a little more about that experience with HCI. And I was thinking as Dilip was talking, it's always funny because I have access to all these labs, obviously being from Dell, where they asked me to walk in with my virtual GitLab tool kit, open it up, and start working on HCI AMD boxes or all the Dell Power star.stars that we have. And I know the AMD tin, or inside the tin, just works, because I'm working on solutions way up here, and Dilip's down here. It's such a, but I just know I have the confidence that these systems flat out work for me and perform for what I'm doing, especially when I'm using a lot of microservices with SQL in a container, et cetera. So using Arc, and you guys specifically, you said you're using AKS, do you have Arc plugged in over the top also right now? Okay. Yeah, Azure Arc enabling AKS, and I have some slides here to kind of lay up the swim lanes or the layers, right? There's a lot of layers we have here. We've got HCI nodes, then we have the HCI OS, then we have AKS, then we have SQL in a container, or web apps, or app services. There's a lot of different layers here that we're running on that same HCI stack potentially. And you'll see in the paper that we carved out a couple different namespaces to kind of mimic real life, application side and databases side. But we did that with Kubernetes construct with namespaces. And then across locations, different edge locations kind of depicting here, maybe with smaller form factor HCI nodes, and then in the core, and then also using Arc to use that single pane of glass, and you'll see that here in my demo. When I first started noodling around or talking with Arc, I think it was actually called Project Tina, right, Steve? I think that might have been what it was called before it came out. Doesn't matter, but I thought, wow, what a really cool way to see, and I know it's an overused phrase, single pane of glass, but this is actually true, especially when it comes to DB as a service. And I came up through EMC and then Dell, and I saw a lot of DB as a service offerings that they made, and I would just kind of, nope, that's not DB as a service. This actually is. This is cool stuff. And then using those tools to optimize the workload placement. Now, a lot of this is, again, auto magic, technical term. When Mike and I were doing some of our testing with lifecycle management again, we're letting AKS and HCI, letting HCI place the AKS worker nodes where it wants to, letting AKS place the pods from Kubernetes where it would like to, across Kubernetes cluster, HCI cluster, a lot of different IP naming spaces there. But you get the idea that this, and I'm happy you guys are using it, because I'm having more and more conversations now for solving for stuff like this, especially from maybe competitor environments, maybe VMware environments where they're running other Kubernetes variants. Clients just want easy or easier, and this is much easier to do. A lot of that work is just taken care of for you, which is a good thing. Simplifying Azure on premises. There I am, lifecycle management. I was just talking about that. So the lifecycle management that we have built in with Dell Open Manage is a plug-in right there with Windows Admin Center. You guys are probably using Windows Admin Center also potentially for your clusters. This is how you're managing your HCI clusters with Windows Admin Center, and that is actually a picture of, yeah, Open Manage right there. I know it's a little blurry, sorry. But that is the Dell plugin for Windows Admin Center, and that's how you manage BIOS, firmware, patching, and updating lifecycle management. It's all done right there. That's a nice tool. Eliminating manual errors, that's a good thing for sure. And then accelerating innovation, which is the place I really love to play, and it's that seamless experience across really any clouds. Moving workloads back and forth between HCI and up to Azure with AKS as the underpinning. The interesting thing to note about AKS is the Linux OS is Mariner, that's Microsoft's version of Linux, and it's Ubuntu up in Azure, but soon to be Mariner also up in Azure and Mariner on premises, so all the Linux OSs are the same. Right now it's Mariner on premises for AKS. So Arc-enabled SQL Server, this is a SQL Server conference. So you can, there's a few different things here. And this is the slide I put together a while back. So way over here, this thing is always so much fun. Way over here is Arc-enabled SQL Server, which is different than what's way over there on that side, which is Arc-enabled data services, but the SQL MI, and we'll get there in a second. This is enabling a server, could be SQL, doesn't have to be, Windows or Linux, physical or virtual, and you get all the goodness. You've probably seen other sessions with RBAC, with Defender, with Best Practice Analyzer. You can plug in and look at all of your entire SQL Server estate with that, and you can actually light it up at install time also. Just need your subscription. There is no free Azure, so as long as you have your subscription and a credit card, you can go to town. Although a lot of the initial features with this are free, and then it's about $6 per server per month. So kind of a nominal charge. The interesting little secret about this is logging. Behind the scenes, logging in Azure, you need to also manage your daily caps because that can get a little overwhelming. And then a lot of what we're going to talk about today in my demo is way over here, the SQL MI or managed instance, which does require this entire layer cake of Dell Kit, HCI in this case, Azure Stack HCI, the Kubernetes clusters AKS, and then enabling that Kubernetes cluster, and then we have the SQL managed instance. Arc-enabled servers first, before we get into the real fun stuff on the app side. You do get this organization and inventory, governance and security. I do a demo actually with this previous slide, which is I'm not doing today, but I do servers and I have Azure Arc, VMware, vCenter, Kubernetes, and app services and SQL MI all on a single pane of glass. All from portal.azure.com. And I look at all of my servers that could be running in HCI, that could be running in VMware, anywhere. I look at all of them, and I get to do RBAC and policies and access across all of them from a single pane of glass. That's pretty cool. So this is from Lior at Microsoft. This is kind of where we're talking today, HCI with Azure Stack HCI VMs. In this case, it's Linux Mariner nodes for AKS. We also have servers running and or SQL servers running, and then connecting up to Azure. So Arc-enabled data services. This is the product that really makes my socks go up and down. I love it. I've wrote probably 5 papers on this topic in the past 16 months. So this is a lot of lines on the screen here, but this data controller, this came from our paper actually. This data controller right here, we called it DB as a service DC01. It's what does just this, everything in that box. It controls everything in that box. It knows where the SQL MIs are. Obviously, then there's hooks down to AKS and HCI. So there's this layer cake I was talking about. 3 AMD AX nodes from Dell, a cluster, an AKS cluster, a namespace, and then up here we have the managed instances. That's a lot of layers. That's a lot of IP spaces. So think about this when going back to the open managed integration and lifecycle management happens. I want to keep my workloads running, and we actually did this. We tested this in the paper. I had HammerDB running against SQL Arc managed instances, or Azure Arc enabled SQL managed instances, sorry. And I thought I was going to lose connectivity, and I never did. The whole time. And my demo I'm going to show her, I have 20 SQL MIs that I run all at the same time. Here's a little different layout of how we did this in the lab. Not the only way to do it, but 3-node cluster, physical cluster, HCI cluster, and then we carved out a couple different namespaces here. I was talking about this earlier, where I have the database namespace, and I have the application namespace. In the application namespace is where I deployed HammerDB inside a container. In the database namespace is where I deployed the SQL MI, or managed instance, in a container. Interesting point to think about here is and I'm actually going to blog about this. I'm writing this blog actually this week, is the performance you get running really anything in a container. I did a few tests last year with HammerDB where I had a big worker node or a big VM, probably 8 gig, 16 vCPU, just to run HammerDB against a lot of SQL MIs in this type of namespace, maybe 10 different MIs. But that's a big VM. Instead, with this recent paper, we carved out HammerDB in a container this time, so my footprint was a lot smaller. I had one HammerDB container that pointed to one SQL MI, and I mapped that for 20 of them, or 40 of them, whatever I wanted to do. We wrote a harness just to fire it off and let it run, and you'll see that. It was highly efficient to see I could run HammerDB with half a gig. And because all I remember from a container perspective, I just need the binaries. All I want to do is run that specific app, just like SQL in a container. I love running SQL in a container, especially when I can stand it up in a couple minutes. I don't need to call my administration team or stand up a VM or do any of that. I just run it right in a container. And then of course, Windows Admin Center way on the left side, your left side here, is how I kind of manage all of this. It's funny, too, to think about personas, because the guy I work really close with over here, he's an admin guy, so he loves all of this. That's where he plays. This is where I play, and this is where I play. So in your organization, it's always, when I talk with clients, I'm curious where the line of delineation is. Is it at the cluster? Is it here? I'm talking about roles, right? Old sysadmins, or who's the Kubernetes administrator now? Is that the old sysadmin? Is that the DBA? I love, and for the DBAs in the room, if you're not doing Kubernetes, please start. Please start. You'll see it's declarative, just like SQL Server. It's the same thing. It's key value pairs. YAML files, you look at it, you're like, wow, this is just like looking at a database or just looking at an attribute and its value. That's why Kubernetes is so cool, and I think once DBAs start really working with it, I get addicted to it. It's like a video game for me almost daily when I'm working in these environments. But it's a lot of fun. How much time do I have left here? Oh, I'm doing okay, good. So, yes, go.
You have the managed instance, right?
Yes.
It runs in Kubernetes, but it's... Sorry, you have the managed instance, Azure SQL managed instance, and it runs in Kubernetes. But I think it's quite pricey, right? You have to pay for vCore. It's quite pricey. So is there another alternative between that? Could you run your own SQL in Kubernetes in AKS?
Oh, yeah, well, you can absolutely. You don't have to use Azure Arc enabled SQL Server.
No. Well, do you have any experience in that?
Oh yeah.
Yeah.
I run SQL Server. Well, I run SQL Server before even Arc came out, the managed instance. You can run. We have papers that I even helped author just running SQL in a container.
Yeah.
Yes. Yes, absolutely. It's the same. You don't get all the managed experience, backups, the automation. The biggest thing about the SQL managed instance is it's always current. It's always the latest version of SQL Server, always. So gone are the days of forklift, backup, restore, upgrade type of thing, or you get stuck. Who's running SQL Server 2008? Here, come on, raise your hand. Someone? 5, oh, I'm sorry. 2000? Data pump, DTS, come on, I know there's some people out here. Okay. Anyway, so that's what it enables. That's what the managed instance allows you to always be current. That's the biggest value add. And you can also play around with it. There's a dev switch deploying. It's not for production at all. I learned this the hard way. In fact, we were doing papers. We wrote our first iteration of this paper when it was still in public preview, and then it went GA, and I didn't have the dev switch, so we started getting charged. Like, oops. And I was doing this in dev environments. All I do is add -- dev in my deployment, and I can keep on working. So you can noodle around with this for free with the dev switch. But then you are charged by requested vCores. I'm sorry, limits. I'm sorry about that. You're charged on limits. In Kubernetes, we have requested and limits. Requested guarantees Kubernetes is going to give you 2 vCPU. So, and this is what was super interesting to me with this paper. Microsoft kind of recommended doing requested and limit the same, maybe 4 and 4. But what that kind of hamstrings my cluster to, if I did requested of 2 and limit of 4, because your SQL Server is not always running at 4. You're going to have this with SQL Server, right? So I want to have it doing the most efficient work. So I set it at 2 requested and 4 for that kind of sweet spot, and it worked really well. So I got a few minutes here. Let's go through this. This is the architecture of the data controller, Arc-enabled data services. Again, that data controller, think of that pod or deployment of pods as the traffic cop. Knows about everything. Notice here, any cloud native computing foundation Kubernetes variant you can use. Does not have to be AKS. There's OpenShift, the usual suspects, Tanzu, upstream Kubernetes. And Postgres is there too. That's kind of making a run, and it's pretty awesome what they can do with hyperscale for sure. And then you're using AZ-CLI, using the portal, of course kubectl commands, and your agents are what's sending up the telemetry and the billing, and you're still using the same tools. SSMS, Azure Data Studio, PowerShell. I use all of it. So let's get to this demo. Yes, go. Sorry?
So how well that survives if it's disconnected from Azure? Does it need to be always connected to Azure side?
You need to connect at least once a month from a billing and telemetry perspective. Yes.
Yeah, they got to figure out how to get their blood from you.
Yes. Yes. So do you have a disconnected environment? Fully disconnected?
Yeah, some of our customers have, let's say, situations where they can be out of contact for a day or 2.
Oh, yeah. Not a problem. No, not a problem. You don't have to be fully connected to run. You have to be connected just to send telemetry and billing. This. Right here. That's it.
And if you're wanting to get updates, right? So this is evergreen.
That's true.
So it's always updating in the background. So you do want to make sure you're running latest. I mean, this is cloud native, right? So at some point, you got to connect to a cloud.
The nice thing about that comment is a lot of what's updated is this data controller every month. And they actually, thank you, Microsoft, started doing this on Patch Tuesday, because I've been working with this product for about 2 years now, and this used to come out sometimes on a Friday afternoon where I was actually going to do something with my weekend, but instead I jumped on this just because that's how I roll. I always wanted to deploy the latest and greatest. But now it's every Patch Tuesday, the new data controller version comes down. So that's a little tip there.
And one last comment here on the nodes. So we're talking Azure Stack HCI, right? But those nodes down here, those could be VxRail nodes.
Yes.
They could be traditional 3-tier architecture server SAN. They could be OpenShift. It's all the things. It's an and story over and over and over again. Mm-hmm. Let's do the demo. Let's see what it looks like in reality.
Okay, reality. That's not reality. That's reality. Okay. So you mind if I sit, Dill? I'm going to put my spectacles on here, and I'm going to zoom in a little bit. So here we are in the at PowerShell. I'm just working in. You can see a long directory tree of a test harness that I wrote, which actually deploys, as I mentioned earlier, HammerDB and Azure Arc enabled SQL MIs. Talk to me later if you're interested in contributing to this. I do keep it up in GitHub. I'm happy to start showing some of this to the masses. So I'll kick this off here real quick. I have a couple different, these are some Kubernetes constructs here. I have remember you saw from my diagram earlier, there's an applications namespace and a databases namespace. Why we did this? Just to probably be nerdy, but I did want to carve out HammerDB into applications and SQL into the database namespace. It let me kind of look at metrics, and you'll see that here in a little bit. So I'll switch my context over to, looks like, applications, and then quickly kick off the auto bench. So here, real quick, is the job restoring the TPCC. If you know HammerDB, it's just restoring the TPCC database. I always like to restore it back to a pristine state. I think looks like I did 20 of them here. So we can watch paint dry here for a second. I think I actually fast forward this a little bit. But they all deployed. There's all of those SQL managed instances. And let's just run using central management servers at version. And there's all of them. They all have IP addresses. All 20 of those I deployed in about 12 minutes. All 20 got deployed in 12 minutes. Those are 20 SQL Server managed instances. And the nice thing here, actually point to mention, using a load balancer with AKS, you can see my IP addresses are all sequential, which is a little nicer than something like Kubernetes with node port, where I get same IP address per the node, but then I get different ports. And it's usually a 5 numeric 31056 type of thing. But at least with AKS, I'm using a load balancer, and I get clean IP addresses. I don't need to use a port because I'm getting IP addresses directly from the load balancer. And here I am using SSMS. I showed this earlier. I'm using SSMS to watch the really cool task of restoring a database that everybody's done. Now I'll jump over to Windows Admin Center. This is some of the tooling. You can see I've been running some workloads here. I just kind of wanted to catch these peaks and valleys to show everybody during this demo of what's getting collected in the dashboard. Now I'm over to the portal. This is portal.azure.com. You can see my clusters. There's the application cluster up top. There's the database cluster, and then, of course, the management cluster. Inside that database cluster, I can go to Insights. Now this is way cool. So Insights here is really interesting, where I can see, hopefully you can see it a little bit here. I have node CPU utilization, but up here, cluster level, node level, container level. I'm sorry, container level right here. So I can drill into all of these layers with insights inside the portal to a connected AKS cluster on premises. Pretty powerful. Active pod count, node count. This is kind of high level. This is the cluster level reporting, but you can drill into this. Takeaway here is you're not flying blind with AKS, because that comes up a lot when I'm talking with clients. They're a little bit afraid of AKS because they don't know how to manage it. Well, or any Kubernetes. Microsoft allows you, or brings that ease of use right here. They're into containers. So drilling into containers now, it takes a second to bring them all back. There's all these Arc-SQL MIs. You can see in that pod column right there, they're all kind of randomly listed. And remember, with a Kubernetes construct, we have the smallest unit of work with Kubernetes is a pod. Inside a pod can be one-to-many containers. You should have a one-to-one. Microsoft, for every SQL MI, has 4 containers inside a pod. The Arc SQL MI, collectd, FluentBit, and an HA container to manage the HA. Even with general purpose, which is what I deployed here, there's 2 different tiers for SQL MI, general purpose and business critical. Business critical being an always-on group. General purpose still deploys an always-on group, but it's just a group of one replica.
Business continuity is Enterprise Edition. Managed instance is effectively the standard edition of SQL. Effectively. Equivalent.
Yes, yeah. Yeah, well,
Because
yes.
I can do always on, I can do all the cool stuff with business continuity, right?
Yes, that's right, that's right. So a lot to show here, right? I'm at the container level now, so now I'm way down here at the bottom. There you can see FluentBit, collectd, all based on one, and the Arc HA supervisor that I just mentioned. So 4 containers per 1 pod. Over at the application layer, go back to Insights now. At some point, I'm going to see all my Hammer DB pods that got deployed. You see some workloads that were running there and a few random tests that I was doing on this day. I was working on this demo. So now I go all the way down into the container level. And inside this namespace, DBaaS applications-1, way down here, keep scrolling, Rob, keep scrolling, are all my Hammer DB, keep going, Rob, okay. All my Hammer DB pods, I think they're going to show up here in a second. This is why it's nice having these tools. So there's all my Hammer DB pods that got deployed. So each number on the far right equates to an equivalent SQL MI in the other namespace. That's how I did this workload test. So back out to still restoring, still watching paint dry. So now let's go over to Azure Data Studio, another tool that we can use to manage our environment. There's those same SQL MIs again, all 20 of them. Now I can look at inside here, I get my connection strings. There's 1433, which is why I didn't call it out in SSMS. I can change CPU, compute and storage, backups. And then I get Grafana. I get a link to Grafana. Grafana is eating the world. So Grafana comes deployed as part of the data controller. What does that do? That gives me on-premises, you see all my pods there, 1 through 20. This gives me on-premises insights into hosts, pods and containers, and SQL managed instances. This comes as part of the data controller. This you get out of the box from Microsoft as part of the data controller. There's the 4 nodes, MOC, you see on the top left there. That's the prefix that Microsoft uses for AKS. And then now, finally, I have, and this is kind of cool to stop this here for a second, running kubectl. I ran it a couple times here. This is going to be cool. It's reversed. So here I had container creating, and now I have all of them actually running. And you can see just one container in those pods, so 1-to-1 for these HammerDBs. So looking at an activity monitor, let's go see if actually HammerDB is doing some work. I see it's connected. That's that the TCL code, the HammerDB TCL code. Now kicking off the benchmarking. So it's connected, and now here comes the load. So I run this with 5, 10, 15, 20, 25 users, kind of stepping it up so I can see it. So I go over to Grafana, looking at the managed instance. Let's pick on MI20 or MI10. And there again is the database workload. I came over here just to see if I saw any work yet, because I know I'm trying to show the relationship between how fast the data gets up to the portal. There's some work starting to be created from a CPU perspective against these various. Here I'm in, on the top left, you can see hopefully you can see, let me zoom in here. Up here are the servers, those MOCs, those are my 4 virtual AKS nodes. That's what I'm looking at this point. So remember, I'm looking at different levels. I've got AKS nodes, I've got hosts, and then, hosts and pods or SQL MIs. This all comes out of the box with a managed instance. Just switching between a few different nodes here. Pods and containers. And then it looks like I do have some work happening over there. I'm looking at these little spark lines, or not actually spark lines, just little charts, where I've got some consumption against all of these Arc SQL MIs. Back over to the HammerDB namespace. There's some work ramping up. And some work from these HammerDB pods, you can see. Is it all equal? No. But they all kicked off for the most part at the same time. And they're all ramping up. Again, using Activity Monitor, just something easy. There's a bunch of transactions being committed. Batch requests are starting to go up. And right here, to stop this for a second, and this is really how I deploy day in and day out with a managed instance, general purpose. Using the Azure CLI, AZ SQL, MI, Arc, create. I give it the parameters that I'd like. I call out the storage classes, the size. You can increase CPU and memory with things like Azure Data Studio. You saw that. Increasing storage is a kubectl construct, not hard to do. I actually wrote about it in the paper. So you can also increase your storage for sure. But that's it. This is how I deploy all 20 of these. I literally highlighted all of this and ran it. And they all deployed. 5 minutes, thank you. So there they all are, 1 through 20. And that's how I deployed them. Super easy. Almost too easy. So easy a developer could do it. So nothing against developers. I'm one myself. Anyway, there's some workloads again and insights. You can see all the metrics that I get. Now here's my SQL managed instances. Page life, all the usual suspects. Memory, CPU. There's so much insight or reporting for SQL managed instance, it almost went the other way. Too much reporting. But this is all out of the box, which is super cool. Pretty excited about that for sure. So let me jump back to close this out here real quick. Was that pretty interesting? Was that pretty cool or a lot? Pretty nerdy? Steve gets on me for being pretty nerdy, but it is a lot of detail. There's a lot of layers. It is SQL bits, yes. So the takeaway here is this, right? There's a lot of tools I used here. The portal, of course. Visual Studio Code, Admin Center, SSMS, tried and true. GitHub, if you don't have an account, please create one. Remoting, right? kubectl, SSH. And I was a Windows guy for 25 years, and only 5-6 years ago, I still have to Google a fair amount of what I have to do with Kubernetes, but it's an exciting place to be. But these are all the tools that just should be in your virtual toolkit every day, as a DBA, as a developer, whoever you are. It's kind of just standard issue anymore. And coming soon for Dell, we actually have our Flex storage, PowerFlex right now. We have it in AWS and Amazon. Any of you running SQL Server there, great. Also coming to more clouds near you. This is only going to expand what Dell does from an innovation and a software perspective, connecting all the clouds using storage that you already use from Dell, which is super exciting for me of where we're going to take these type of solutions, kind of agnostic of clouds, but keeping Dell as the fundamental underpinning across storage, data protection, and compute. And this is also going to include containers. Super cool, this space right now. So keep watching this, more to come later this year for sure. Continued learning, that link up on the top, the first one there is the one that we just updated, just dropped last week, is all about the demos and the whole stack and everything that we did in today's conversation, plus a bunch of other papers that I've written here over the past year or so. A lot of really cool stuff. And Dell keeps doing this. We got more coming here this year. So my plate's full.
Yeah, when in doubt, infohub.delltechnologies.com.
Absolutely.
You can find all this. You can just click on the SQL and it's all clustered.
Yep, infohub.delltechnologies.com. So thanks everyone. Feedback, please. I'd love to have some really cool feedback from this session, especially Kubernetes, SQL, and managed instance. Hopefully you learned something. I'm here to talk. I'll be here all day probably, just working in the back. So I'm happy to talk about anything.
This is the thought leadership of where database is going, right?
Yep.
So for decades it's been SQL and Windows Server, but we absolutely see this is the future. This is where it's going. And it's just a matter of time before it swallows you. So the quicker you get ahead of this, the quicker you start learning the polyglot, the quicker you start recognizing that Linux is the Borg, it will assimilate you, right? Resistance is futile. It's coming. And everything becoming a subscription. Heck, even Dell, right? Even our infrastructure as a service with Apex. Pay as you go, that's the new reality. That's where everything's going. So please give us, these are very specific to the sessions, feedback. Let us know if we're on the right track. We think we are, but we'd like your validation. This is where the hockey puck's going, right? You want to skate ahead. So it's a brave new world out there. Hopefully we'll get you enabled and dangerous, right? Thanks, Rob.
Yep. Thanks
Dylan.
everyone. Appreciate it. Thank you.